a few little skills and concepts here, right? Three angles add up to 180. You can calculate x. Once you calculate x, you can plug that in to get the angle measures, which you see I did that here. I plugged in x and calculated the three measures, 16, 109, and 55 degrees, and that would be total 180. In number 2, I was just matching up the corresponding parts based on the markings, right? So angle A has 2 marks, 2 arc marks. So I said, well, that has to be congruent to angle Z because it has 2 arc marks. Angle B has 1 arc mark, right there, and that must be congruent to angle Y because angle Y has 1 arc mark, and then angle C has 3 arc marks, along with angle X. So those have to be congruent. And then the sides, well, I use tick marks for the sides. So side AB has 3 tick marks, so it's congruent to YZ because it has 3 tick marks. AC is congruent to XZ, and we know that because they both have 1 tick mark. And then BC is congruent to YX because they both have 2 tick marks. We also talked about how YZ is the same as ZY, XZ is the same as ZX, and YX is the same as XY. And then when I did this, triangle BAC is congruent to triangle blank. I filled in the blank by looking at the markings on B, A, and C. B has 1 mark, A has 2 marks if you look at the triangles, and C has 3 arc marks. So I followed this pattern of 1, 2, 3, as in 1 arc mark, 2 arc marks, 3 arc marks, 1 on B, 2 on A, 3 on C. So I followed that lead over here. Y has 1 arc mark, Z has 2 arc marks, X has 3. So you got to use something to make sure you name the triangles in a corresponding order. So there's that. And then we did problem 3A and B. 3A was an isosceles triangle, as you see here. What was blank is that these 2 angles were blank. We had isosceles triangle. We marked it isosceles. Give me 1 second. Once I know it's isosceles, I would have to know that across from the 2 congruent sides, I have 2 congruent angles. So if this one's 35, this one has to be 35. And then once I have those 2 angles, I can get the third one because 3 angles need to add up to 180, right? So 35 plus 35 plus question mark equals 180. And finally, I can get the measure of angle K is 10. But again, I did have to use two concepts there. The concept of the isosceles triangle having 2 congruent angles across from the 2 congruent sides, as well as 3 angles in a triangle add up to 180. So nothing too complicated, but nonetheless, it's a couple steps. On this one, they showed me, if you look at the original drawing, they showed me that one side is 9, and they also showed me all 3 angles being congruent. If all 3 angles are congruent, that means all 3 sides are also congruent. So each side here is 9. So HI has to be 9. The fact that the 3 angles are all 60 was just an extra little thing I threw in. You didn't have to say that they were 60, but again, a little extra piece of info. If all the angles in a triangle are equal, they have to be 60 because total has to be 180. So let me go ahead and let that be. I'll post a video of this later. I'm recording this right now, which is me explaining. So you'll have access to either the explanation or just the work itself. Hopefully we can just get through this today and maybe have time to plug along to the next. We'll see. This next one's an isosceles triangle, and they actually set it all up for me. All I need to know is that in an isosceles triangle, opposite from the 2 congruent sides, right? Opposite means across from. So across from the 2 congruent sides, I have 2 congruent angles. Well, since I know that the angles are congruent, I can then say, okay, well, 2x plus 34 equals 5x plus 7. If the angles are congruent, then those values have to be equal. So that is the jump you guys are all going to have to make. The jump into writing equations based on what you know in this, geometric context. So again, once I realize these 2 angles are congruent, I can then set them equal to each other and solve. So I can subtract 2x here. Normally, remember the steps for solving an equation: L, DC, MAM, L for a line down from the equal sign, D for distribute. There's no distributing on this side, and there's no distributing right side either. Then C, combine like terms. There's no like terms here on the left, and there's no like terms here on the right. And then after that, it would be M, move the variables to the same side. So normally I'll move the lesser of the two. So moving the 2x over, bring down the 34, and 5 minus 2 is 3, so 3x, bring down the plus 7. I'm ready for my next step, which is to undo any adding or subtracting. That means this plus 7's got to go minus 7 both sides. 34 minus 7 is 27, and 27 equals 3x. The 7 cancels or zeroes out. So one last step here, divide by 3. And I can see now 27 divided by 3, x equals 9. And in this problem, number 4, find the degree measure of each angle in the triangle. Okay, well the measure of angle B, measure of angle B and A are the same, so, but you can use your answer for x to plug in and actually make sure they come out the same. If they don't come out the same, there's a problem. So 2 times 9 plus 34, so that's 18 plus 34 from angle B. 62 degrees for angle B. A should also come out 62. If A doesn't come out 62, then I did something wrong, because remember A and B are equal. Measure of angle A, 5 times, remember x is 9, 5 times 9 plus 7. Wait a second, I think I did something wrong here. Oh yeah, there it is. This is 52. 34 plus 18 is not 62, it's 52, so there's my mistake. Sorry about that. Now it's looking a little sloppy, but again, it should be 52, not 62. That's my mistake. And over here, 5 times 9 plus 7, well that's 45 plus 7, which is also 52, so I can feel pretty confident at that point because they're supposed to be equal and they both came out 52. My last step here is it says find the measure of each angle in the triangle, meaning also angle C, so remember 3 angles in a triangle add up to 180, so the measure of angle C plus, remember this is 52, and A is also 52, so add 3 angles in the triangle, it has to add up to 180, so the measure of angle C plus 52 equals 180, and 52 plus 52 is 104. Now I can subtract that, and the measure of angle C. The measure of angle C is 180 minus 104, 76 degrees. So we could double check that too. Don't forget you can scroll down and check your answers here for number, let's see, number 4. Okay, I went too far. 52, 52, and 76. Sounds good. Okay, number 5. Let's see. For each figure below, determine by using the markings if there's a pair of congruent triangles. If there is, name the congruence and give the property justifying the congruence. Well, remember these guys? This is like, does do any of the congruence theorems that we've looked at apply here, right? I'm going to just kind of side note this. Right, triangle congruence theorems. Triangle congruence theorems. I believe the first one we took a look at was side congruence. All 3 sides of one triangle are congruent to all 3 sides of another triangle, and the 2 triangles are congruent. Another one we looked at was side, angle, side, angle, side, angle, 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 side, and we also looked at one called hypotenuse, leg. So, and then we had some that don't work, angle, 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 as well as a angle, side, side. That doesn't work either. So if you look at A, I mean we could draw something out for A. Probably be easier than trying to use the electronic tools. Anyhow, let's go ahead and draw something out here for A. I'm going to draw out one of these triangles. You guys stop me if you have a question. So I have triangle MNO, and it has a tick mark and an arc mark there. And this is something I advised you guys back when we were doing these before we went on break. I said, well, if you have an angle marked congruent to another angle, maybe mark that angle with an A. If you have a side marked with a tick mark congruent to another side, mark that with an S. And that's all I have. I just have an angle on a side, and angle side wasn't one of our triangle congruence theorems. So let's see what it says. Determine if there's a pair of congruent triangles. If there is, name the congruent symbol. So we're just going to say not congruent for A. There's no theorem called angle side or just side angle. There's angle side angle, but not just angle side. There's side angle side, but not just side angle. So that's definitely not congruent there for A. If you look at B, I think you can kind of get this with, not necessarily congruent. My bad, I didn't realize that was there. Well, that's good enough, not congruent, or not necessarily congruent. That's a good point. It doesn't, we don't have proof that they're not congruent, or we don't have enough proof to say they are congruent either, so not necessarily congruent is probably a better answer than just saying not congruent. Either way, HIG, you guys, is one of the triangles here. HIG has 2 arc marks on I, 1 tick mark on HI, and 1 arc mark on H. This is going to be one of our congruence theorems, right? We have an angle here, a side there, and an angle here. Let's go ahead and draw the other one out. Okay, so there it is, and again, we have an angle here, a side here, and an angle here. So if you don't know which theorem it is, well, you got to kind of take a look at what you have here. If anyone wants to chime in, but you're definitely welcome to. Anybody want to chime in on this? Which theorem is all good here? Which theorem would apply to this? These are definitely 2 congruent triangles based on good, thanks, Abriana. Based on the angle side angle theorem. Let's see what we have here. I'm going to say congruent by ASA. We'll just say by ASA congruence. And we're also going to fill in that other thing, that triangle GHI is congruent to triangle blank. Well, if you look at GHI, if you look at G, notice how the angle G has no marks on it, and then look at H, notice how H has 1 mark, and then I, notice how I has 2 marks. So as I name this triangle, I have to name it in a corresponding order. I have to name it with, the angle that has no marks should be the first letter. Then the angle that has 1 arc mark should be the second letter, and then the angle that has 2 arc marks should be the third letter. So basically I'm thinking 0, 1, 2 as in 0 marks, 1 mark, 2 marks. Anybody want to chime in? What triangle name would correspond with GHI? Again, 0, 1, 2 is kind of my go-to. Yeah, that looks about right to me. Brianna, thanks for checking in. LKJ, because 0, 1, 2, 0 marks on L, 1 mark on K, 2 marks on J. So LKJ, again, that would be a corresponding order to GHI. Once you have one correct congruence statement, you can then use it to check any, different congruence statement for the same two triangles. Like if you called it IHG, if the first triangle was called IHG, well, that's, third letter, second letter, first letter. So if you called the first triangle IHG, then you call the second one JKL. So just however the first triangle gets named, the second one must be named in a corresponding order, okay? So you guys are, maybe I should let you be on the next one. You can practice a little bit here. I think it makes sense to draw it out, but perhaps you can answer it as best you can here. So C is, here's a triangle ABC, and AC has 1 mark, AB has 2 marks, and angle A has 1 arc mark, right? So tick marks are the sides, what we use for the sides, and arc marks are what we use for the angles, and we also have triangle DEF. And the markings, you can see where they're at. DF has 1 tick mark, F has an arc mark, angle F that is, and then EF, side EF has 2 marks. So and you guys can, you can mark an A on the angles and an S on the sides that are actually congruent. And if you do that, you should be able to pick out the congruence theorem pretty quickly. Let me know if there's any questions. You guys here, let me know if there's any questions. You have paper, miss? You good? I'm just checking. I just want to share if you don't. So, any takers on this one? Anybody know which theorem we can use to say that, triangle blank is congruent to triangle blank? In fact, it says triangle ABC, so I'm going to go ahead and take that piece and copy it. Triangle ABC is congruent to triangle blank. You don't have to mark up the triangles, you guys, but you can, right? You can mark up the side here, the angle here, and the side there, right? If you mark them up with an S and an A, an S on the sides and an A on the angles, well, FED probably makes sense, but let me double check that. Also, which congruence theorem, right? So these triangles are congruent, right? We would say congruent by SAS, SSS, AAS, or ASA, that is. Anybody want to chime in on that part? Albriano, let's check your answer, though. Let's see. We have ABC here, ABC. Here's what I have to kind of think about. How A has 1 arc mark. B and C are both blank, so naming it ABC, I got to pay attention to the fact that it has these 2 tick marks as I go from A to B. So again, start where there's 1 arc mark. Make sure you pass over 2 tick marks as you go to your next letter, and then, of course, the third letter is going to be just the last one. So let's see if FED is correct. Starting at 1 arc mark, and then over to E, passing over the 2 tick marks. Yes, you are right. It is FED. So good, and thanks for chiming in. And does anybody have the congruence theorem right? So you're supposed to say 2 things. If it is congruent, you're supposed to say which congruence theorem proves it, and then, of course, this part where you name the triangle. So, anybody get the congruence theorem here, right? We have a side here, marked congruent to a side over there. We have angle here, it's marked congruent to an angle over there, and then we have another side here marked congruent to that side over there. So anybody want to chime in? Which congruence theorem applies here for number, what is it, 5? Number 5C. Yep, side angle side. Thanks for checking in there, Brianna. So there's your answer. They're congruent by side angle side, and triangle ABC is congruent to triangle FED would be a corresponding order to name that one in. The next couple, they're like, well, you can see they're basically proofs, which we haven't done yet. So proofs are basically when you write out all the different parts that are congruent from the triangles, and you give a reason why they're congruent, and then you at the end you say something like what it says here: triangle blank is congruent to triangle blank, or triangle PQR is congruent to triangle RSP by whichever theorem applies. So I'll just leave this for a couple more seconds, then I'll plug along. So this is the one topic we haven't got to yet, the proofs topic. So kind of just use these two problems to intro proofs to you, but don't get too overwhelmed. It's, probably to be expected that it's a little bit tricky because it's brand new. This is basically a 2-column proof. In a 2-column proof, you give the statements in one column and the reasons why those statements are true in another column. This stuff up here is like the given information, the sketch, and then the 2 pieces of information here that say given, that's the given information. So you use the given information to eventually prove the 2 triangles are congruent. So we haven't done proofs yet, guys. This is kind of like your first look at what a proof is. And again, this is a 2-column proof, so I think we should just kind of draw this out. So normally with a proof, that's what you would do, is draw it out, write down all the info, and fill in the 2 columns. What do we have here? It looks like a parallelogram. This is number 6. Hang in there, guys. I know this is not the most exciting thing, but hang in there. So we have this quadrilateral divided up into 2 triangles, and the vertices are QPRS. Or PQRS. The given information is that PQ is congruent to RS. Remember, that just means they're the same length. And QR is congruent to SP. And I'm trying to prove that triangle PQR is congruent to triangle RSP. So this is honestly kind of like the previous problems where you had to decide if 2 triangles are congruent based on the parts of the triangle that you knew something about. The only difference here is that you just have to write it out in this, like, I guess this formal this formal 2-column proof style. So your statements and your reasons. Notice how some of it is filled out already, guys. Statement number 1, PQ is congruent to blank. Normally you can start a proof off with the given information. If you look at the given information, you guys see it says that PQ is congruent to RS. So RS is our first blank to fill in, and the reason that PQ is congruent to RS is because it's given. Here's what you want to do with what you know, that you want to mark it on the diagram also. So PQ is congruent to RS. Well, mark that with some tick marks, right? Put a tick mark on QP, tick mark on RS. Next reason, or next statement, QR is congruent to SP. And anybody know the reason that that's true? QR is congruent to SP. Oh, good. Cynthia, you got this. Yeah, look at that. The QR is congruent to SP. Whoops, I didn't put the line there. It's also given. Right? It's given that QR is congruent to SP, but don't forget to mark it. Put double tick marks. Put 2 tick marks on QR and SP. Those are congruent. Now let's go to the next one. Number 3 statement is PR is congruent to blank by the reflexive property. I'll move forward with this one. The reason that this is reflexive property is because PR is congruent to PR. I'm going to put the exact same thing here. PR is congruent to PR. So one way to remember it's called reflexive property, guys. Well, what do you see when you look in the mirror, right? When you look at the mirror, you see exactly what's in front of the mirror, right? So it's called your reflection, right? When you look in the mirror, you see a reflection, aka the exact same thing is in the mirror as what's in front of the mirror. So here it's kind of the same thing, right? If it says reflexive property here, that would be because it's the exact same thing on both sides. So reflexive property, again, it's whatever's on one side is just reflected onto the other side, but don't forget to mark it. If PR is congruent to PR for both triangles, well, we can mark 3 tick marks on that side. And then the last one, triangle PQR, is congruent to triangle RSP. Well, look at this triangle, right? There is a congruence theorem that proves these 2 triangles are congruent. I don't know if any of you guys here know which congruence theorem would prove these 2 triangles are congruent, right? Or anyone online. Does anyone know which congruence theorem would prove that the 2 triangles are congruent? Remember, side note here, remember that you have a few different ones to choose from, right? You have side, 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 angle, side, angle, side, angle, 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 side. Which of these congruence theorems actually can be applied in this? Oh, yep, good stuff. I see that there, Brianna. So thanks for chiming in. It's side, side, side congruence, guys. Triangle PQR is congruent to triangle RSP by side, side, side congruence. And you can draw in like some lines if you like. Make it like a full-blown table if you like. Technically a 2-column proof. What was I gonna say? Oh yeah, you can double check this PQR. Notice the order in which the first one is named PQR. Notice how it crosses over 1 tick mark and then 2 tick marks. So that's why the other one is RSP, because it should follow that same pattern. When you name a triangle, when you name its congruent corresponding triangle, all the parts should match up. So like, QR should be the same length as SP, right? The second and third letter here, QR, should correspond with the second and third letter here, SP. So QR and SP, yeah, they are equal. Or if you looked at QP and RS, those two are equal, so they should be in a corresponding. The letter should be in a corresponding place here, QP and SR. So anyhow, that's why you need to name the triangle in a certain order, because all the corresponding parts need to match up, and that's the only way to get that done or the only way to be accurate is if everything is done in a corresponding order. So I know that's a lot. I know you hadn't seen a 2-column proof before this, so that's kind of a new thing. Question 7, we can definitely do this one also. Use the given information to prove that triangle DEF is congruent to triangle HGF. You see the diagram. You see it's given that EF is congruent to GF, and it's also given that angle EDF is congruent to angle GHF, and we can label all of that stuff. We can sketch it out and label all of it. So let me know. Stop me if you have a question. Okay, number 7 is, well, you can, again, like I said, you can sketch it out here. I have D, E, F, G, and H. Given that EF is congruent to GF, I know these proofs are a little bit labor intensive, so try your best to get it done. Hang in there with me. Also given that angle EDF is congruent to angle GHF. And then I'm trying to prove that triangle DEF is congruent to triangle HGF. All I've really done so far is copy down the info that's already there. I haven't really thought too much about this one yet. And then your 2-column proof, you guys, remember statements and reasons. The statement column is where I say, what is congruent to what, and then the reason is like why or how I know they're congruent. So EF is congruent to blank. You guys should be able to just look at the given info and fill that in, because it says given over here. Right, the fact that it says given there makes it pretty straightforward to fill in the blank. EF is congruent to, anybody want to chime in? Yep. Good. Ariana, Cynthia, thanks for chiming in there. Right, it's given that EF is congruent to GF. In fact, let's go ahead and mark that. EF is congruent to GF. I'm going to put some tick marks on that. Number 2, angle EDF is congruent to angle GHF. EDF is congruent to angle GHF. Anybody know the reason for that? I'm going to go ahead and mark that actually. Angle EDF, remember EDF, you're outlining it, it's this angle here, EDF, is congruent to angle GHF. So Remember, the middle letter is the vertex, so the angle at D, because D is the middle letter, and the angle at H, because H is the middle letter, those are congruent. And does anybody know the reason for that? Just look up here, and your reason might just pop out at you. How do we know that these two angles are congruent? Okay, thanks for that check in there, Aubriana. Yeah, that's given info. If you guys look at the given information, angle EDF is congruent to angle GHF is there. Number 3, angle DEF is congruent to angle blank. Angle DEF is congruent to angle blank. Let's go ahead and mark angle DEF. Or my bad, it's DFE. Where did I come up with DEF? It's DFE that actually matters. It's not DEF. It's DFE. So DFE is congruent to angle blank. So I'll stick to my same color. You do have to put 2 tick marks though, since we already put 1 tick mark on those other angles. We have to put 2 here. Angle DFE is congruent to angle blank. Oh, and it actually tells you it's vertical angles here. So who could name the angle that is vertical to DFE? Vertical angles. Vertical angles are always equal. Okay, Aubriana, you chimed in. HFG, excellent, that is correct, right? These two angles here are vertical, so those are the ones that we should be marking, and yeah, we can definitely call it HFG. GFH or HFG, that's something you guys should know, that angle HFG, you can also call it angle GFH, it's the same angle either way. Thanks again for that chime in there, and now I have my last statement, DEF is congruent to HGF. So we need to fill in this last blank. Basically, we're just looking for which congruence theorem applies here. Let's see. We can actually even use number 3 to check number 4. Notice how we have DEF here in number 4. We could look at number 3 and say like, okay, DEF is in the order first, third, second. Again, if I took the order DEF and tried to see how it relates to DFE, I'd say, oh well, DEF, the order is first letter, third letter, second letter. So if I go here and use the first letter, third letter, second letter, I get HGF, which is actually here. So everything's kind of matching up. I see you put angle side angle here, Cynthia. Well, let's double check that. There's definitely an angle here, and another angle here, and a side there. You're close because you have angle side angle has 2 angles and a side, but this one actually does have to be angle side. There's a difference, right? If it's angle side, it's because the side is non-included between the 2 angles. Again, it's angle side because the side is non-included between the 2 angles. If it was angle side angle, it would have to be the side that's included between the 2 angles, right? If it was angle side angle, it would have to be this side between the 2 angles. Since it's not between the 2 angles, it's non-included, it does have to be angle side. So much appreciated the chime-ins, guys. That pretty much concludes the assignment from yesterday. I could kind of look at the Desmos with you that I posted for today, but we just have a couple minutes left.